Hello, today we'll be working with the synthesis of the tetraphenylcyclopentadienone. This corresponds to our reaction of your chapter 34 of your book. We're going to be using previously synthesized benzyl and dibenzyl ketone. Here we will show the mechanism of reaction. So one first hydroxyl group removes an alpha hydrogen from the dibenzyl ketone, leaving one anion. This anion is later going to attack one of the carbonyls of the benzyl, and we're going to incorporate this 2-skeleton aromatic compound to the other 2-skeleton aromatic compound, generating an anion. This anion will undergo protonation by the solvent. After this, an anion in the solvent is going to remove the neighboring carbon where the hydroxyl group is, and by effects of an elimination reaction, we're going to be generating one hydroxyl, we're going to generate a double bond, and we're going to protonate the species that initially was an anion. Then an anion in the solvent is going to remove the other alpha hydrogen from the other side of the dibenzyl ketone molecule. This will generate an anion. The anion then is going to attack the other carbonyl that belong to the benzyl skeleton, and we're going to be generating this 5-member ring where we're going to have one anion. Yet again, it's going to be protonated by the solvent, and then we're going to exert another elimination reaction from an anion in the solvent, producing this 2 double bond species that it's a 5-member ring. This product is deeply purple. The appearance of the color is a consequence of the increase of the pi electron conjugation and sign that the reaction was successful. So resonance reveals anti-aromatic character of the cyclopentadienone ring. Note that in this resonance form, the 5-member ring has a 4 pi electron, making it a 4n pi system or anti-aromatic. The anti-aromatic character of this molecule makes it much more reactive toward the next step in the synthesis of hexaphenylbenzene, which is the last synthesis of this course. For the experimental procedure, we're going to be using 1.05 grams of benzyl, 1.05 grams of dibenzyl ketone, 20 ml of ethanol, 0.15 grams of KOH, potassium hydroxide, and 2 boiling chips. We're going to attach a reflux condenser into this equipment, and we're going to bring to a gentle boil and reflux it for 15 minutes. The mixture will turn deep purple, and then we're going to cool to room temperature, and then we're going to bring our reaction to the ice bath. We're going to collect the crystals on a Buchner funnel or vacuum filtration and wash with 10 ml of water and then 10 ml of cold ethanol. We're going to allow the product to air dry, check the weight and calculate the yield, and then check the melting point. So practical consideration, the product has a deep purple color as we said, and recrystallization is not necessary. For safety, KOH is a strong base that can cause serious chemical burns, both as a solid and when in solution. Remember to get the IR and the proton NMR spectrum, and this molecule we will also be able to get the UV spectrum in chloroform.